Hey guys, so I had mentioned videos too long, so I gotta be quick, and I know we did a lot of these in class, so I'm just gonna do a few. So anyhow, on these ones, remember the skill was just to change these mixed number fractions, right, mixed number, to improper fractions. So remember, all we had to do was multiply here, right, multiply the 4 times the 2, right, 4 times 2 is 8. Don't worry about the negative at the end. That's an 8. Sorry, I don't have that much space here. Either way, take that 8 and add it to the 3. And remember, since it makes this loop, I said that strategy can be called lupito or lupita. So anyhow, again, 8 plus 3 is 11. So my answer is negative 11 fourths. The whole value was negative, so it stays negative there, so that's that one. And again, I'm not going to have time to do all the problems on this video after all, so just know all it is you loop from the bottom up, you multiply the denominator by the whole number out here. 9 times 2 is 18, then 18 plus 7 is 25, right? So this one would be 25 ninths. And the trackpad is also kind of slowing me down, but I just have to do it this way right now. So there's that. And then okay guys, so this next little set right here, I just kind of have a few on screen, just going to show you how to do one of each or something like that. So right here we have improper fractions that we're supposed to make into mixed number fractions, right? And all I told you on this one was to divide, and I told you, well, remember the top number is the numerator, bottom number is the denominator. So then I related that to some other words, niño and dog, and it was simply a strategy to help me remember how to set these problems up. Remember, niño means boy, and obviously dog is a dog, but either way, the context was this is like a house, and the question was, well, if you had a boy and a dog, right, a niño and a dog, and one of them has to sleep inside and one has to sleep outside, who goes inside? And ultimately it was the boy has to go inside and the dog goes outside. So 42 is inside of here, right? It helps me set up my division, right? The niño over dog idea. And then the dog on the bottom goes outside, and so the niño over dog concept only helps me set up the problem. I still have to do long division, so I'm going to do that real quick. You know what, let me do this one since I already did that other one in class. So anyhow, niño over dog, remember the boy goes inside the house and the dog goes outside, so niño's on top. Alright, oops, almost messed that up. See? Even though I'm using the strategy, I can still mess it up if I don't think right. So the top number is the numerator, aka the niño. The boy goes inside the house, and then the dog would be the denominator, the bottom number, and that goes outside the house. So I'm just going to make that 8 out of that. And then when I'm done here, my answer will still be negative, right? So anyhow, 8 doesn't go into 2, but 8 does go into 29, right? 8 goes into 29, what, 3 times? 3 times 8 is 24, right? Just kind of following my long division steps. My last step here is to subtract. 29 minus 24 is 5, and in this one it doesn't want a decimal, it just wants a mixed number, from improper to mixed number. So the answer is 3 and 5/8. The remainder 5 becomes my numerator, and the 8 on the bottom doesn't change. So 3 and 5/8 is aka, well, better make sure we make that negative because it was negative to begin with. Negative 3 and 5/8, so there's that. And again, the 3 is part of the answer, and then the 5 is the new numerator, and 8 is the denominator, so negative 3 and 5/8. Again, remember these strategies, these little strategies with cute names, there's a document I attached to this assignment where you could see the different strategies and also all the answers, right? I posted those, so we're going to move along. All these right here, I still use the niño over dog idea to set it up, so I'm going to do this one. I'm going to do the 5/11ths because that's one I didn't show in class. So 5/11ths is going to be 5 divided by 11, which looks like this. If you use the Nino over dog strategy, the top number, the boy, goes inside, and the bottom number, the dog, the denominator, goes outside. So it would look like this. And remember, you have to start adding you have to add a decimal place and start adding zeros. And I asked you guys to do this and go 3 places, so hopefully I can squeeze that in here. So 11 doesn't go into 5, which is why I added the 0, because 11 does go into 50, right? 4 times 11 is 44, and then we're going to subtract, and 50 minus 44, right? That's 6, and I'm going to bring down another 0, and that gives me 60 here, and 11 goes into 60 5 times. 5 times 11 is 55, so I'm going to subtract next, and 60 minus 55 is 5, and it looks like I'm going to have a repeating decimal here because I already had 50, and when I add one more 0, and bring that down, I'm going to end up with a 50 down here, which I already had. So this looks like it's going to be a repeating decimal because 11 goes into 50 4 times, and so this looks like it's going to be 0.45454545 forever. But I asked you guys to, for this skill, go to 3 decimal places. So I'm out of space, and I do have my 3 decimal places, so I'm just going to let that be. 5/11 is approximately that, and it will repeat. Hey, so guys, again, I gotta keep moving here. These ones are all these are simply a matter of knowing your decimal place, right? The first place is the tenths, the second one's the hundredths, the third one's the thousandths, then it goes 10 thousandths, 100 thousandths, millionths, 10 millionths, and so on, right? So all I need to know is what place my final digit is in, and I can write this as a fraction. So remember from class, we did these 7/10ths. The 9 is in the hundredths place, 49/100ths. Here the 8 is in the thousandths place, so 48/1000ths. And then I said you have to reduce if possible. I'm gonna go here now. So this is a 9 in the 10th place, right? So AKA as a fraction, it's 9/10ths. This next one is a 6 in the hundredths place, so my 86 is 86/100ths, and that's definitely reducible, so definitely we're going to want to do that. Don't forget to reduce. These are both even, right? So if I divide by 2, that can reduce it for me. 86 divided by 2 is 43, and 100 divided by 2 is 50, and that's about fully reduced. I'm pretty sure 43 is a prime number anyhow. And then this last one, in the 3rd decimal place, we have a 3, which is the thousandths place. So this is 3/1000ths, and can't reduce that, so done deal. And let me move along to these. Remember, these repeating decimals, all these steps here turned out to be unnecessary. A few years ago, I already told you guys, a student taught me how to do these, where if you have a repeating decimal and every digit in the decimal place repeats, it's easy to do. So like the ones that are, these two would be easy, and the one where only part of the decimal repeats is the pain. So anyhow, let me just move along here. Like I said, a student taught me this a few years back. You have a repeating decimal here. Normally 0.79, if it was just 0.79, it would be 79/100ths. But the student told me, well, all you got to do is make it, instead of 79/100ths, if you make it 79/99ths, you will have now, instead of just 0.79, you will have 0.79797979, which is what that is. So again, all I need to do is figure out what, same as the ones above, what decimal place this last digit is in, and then subtract 1 from that. For example, 9 here is in the thousandths place, so if I subtract 1 from 1,000, I have 999. And so basically what I'm saying is this 0.529 repeating decimal, right? 0.529529, it would keep doing that, can be expressed as a fraction, not 529/1000ths, but 529/999ths. And since time is of the essence here, I'm just going to say let's just let that be for now. If it is reducible, we're going to skip that. And now this one. This one is a pain, right? And I'm going to just go through the steps. This one, only the 7, 9 repeats. The 1 doesn't repeat. Only the 7, 9. So anyhow, the way we do this is we make an equation where we say we choose a variable. I'm just going to use n because that's what it says, and then in that context I write that n equals the repeating decimal, meaning I actually write out the repetition a couple times. Since this one is already getting kind of long, I'm just going to repeat it twice. And basically you do that, and then the instructions say you have to decide what to multiply by 10, by 100, by 1,000. You need to decide what to multiply by based on how many digits are repeating. So basically I'm going to multiply this equation by 100 because I see 2 digits repeating here. A lot of these steps in this particular skill set can kind of vary. Like if you multiplied by 1,000 or whoops, that should be 100n, not just 100. 100n. And what I was saying is that this skill set, or this skill with all these steps, can probably be done either way, whether you multiply by 100, 1,000, 10,000. You can still get a pretty fair estimate of a fraction to represent that decimal. So anyhow, if you multiply by 100, you're going to get this decimal will move 2 places to the right. Yeah, multiply by 100 will do that. So this will become 17.979 if I do that, if I multiply by 100. And then the next step says subtract this equation from this one. So basically it's going to be minus the equation that says n equals 0.17979, and since this process is already tedious, I would use a calculator for this part because I don't want to make a mistake on the arithmetic. I'm having enough trouble just going through all the steps, so I definitely don't. That's supposed to be a 9. I definitely don't want to make a mistake just subtracting. So anyhow, 100 minus 1 is 99, so 99n. And alright guys, so I ended up having to erase this, but you can rewind to see the other steps. So I left off on the step where I had 99n, and I went ahead and subtracted the 17.979 minus 0.17979, and I got this. I got 17.79921. So like I said, definitely want to use a calculator on this part because all those decimals, no need to do that by hand, just use a calculator for that part. 17.79921, and as I did in class, I'm going to go ahead and solve the equation for n, meaning I'm going to divide by 99 to get n by itself. So divide both sides by 99, and essentially this is my answer, other than this fraction will give me the decimal 0.17979, but you don't want to have decimals inside your fraction, so all we're going to do is move the decimals over the same amount, right? I have to move this over 1, 2, 3, 4. I have to move the top decimal 5 times to get rid of the decimal, so that'll become 17.79921. Oh, that got really bad right there. 17.79921.
On August 19th, 2003, Wayne Gully is convicted of murder and sentenced to 50 years imprisonment.
Right, and then since I moved it 1, 2, 3, 4, 5 times, that means I have to add 5 zeros to this for it to be accurate. And basically, if I punch this into my calculator, 17.79921 divided by 99 with 5 zeros after, I guess, what is that? Let's see, 2, 3, 4, 5, so what are we looking at? 3, we're looking at over 9 million. So anyhow, if you punch this in your calculator, you will eventually get 0.179